Okay, in the second part of the first chapter, we will talk about hybridization and bonding, starting, from page 10 of your study guide. I told you my lecture is based on chapter 1, but because I'm going to work on the examples from study guide, I will refer to the pages on the study guide. So at this point, I'm not going to ask you to go over the details for hybridization because first of all, you must have had them in General Chemistry 1. Those of you who say that no, your professor didn't go over it or you can't remember it, I don't want you to know all the details because this is not what we're focusing and what we need for organic chemistry. I just go over one type of each hybridization that we need for the organic compounds. First of all, hybridization, remember you had sp, sp2, sp3, and for inorganic compounds, you had the other orbitals like d orbitals involved. But for the good news is that for organic compounds, you just need sp, sp2, and sp3 orbitals. And if you remember, hybrid, the word hybrid means mix. So s and p orbitals mix and they will form hybrid orbitals, and then these hybrid orbitals will bond with each other. So for example, the very easy example is methane molecule. I feel like I need to change my marker for you all to see better. So let's talk about the hybridization in methane molecule, in CH4. Let's talk about go over the electron configuration of carbon first. 1s2, 2s2, and 2p2. Do you remember that we had orbital diagrams? The circles or the cubes, the squares with the arrows as electrons, and because the two electrons with the opposite spins should stay together in one orbital, we show them with opposite directions for arrows. For p orbitals, we have 3, so I'm not going over basic stuff. If you have forgotten everything about orbitals, please go over your general chemistry notes or a general chemistry book. So, if you draw the Lewis structure for methane molecule, you will see there are 3 exact same bonds for this methane molecule. Means exact same thing has happened, the bonding. But if you look at these orbitals, you will see that first of all, you only have 2 single electrons to form the bond with the single electrons in hydrogen, but here you have 4. So we need to have 4 orbitals available. What is the only solution? Is that electron jumps from s to p and form s1p3. Then these orbitals, s orbitals are here, p orbitals are higher. In order to form exact same orbitals, hybrid orbitals, let me draw it. The energy level should be the same. So we call it degeneration. The degeneration happens and 4 exact same hybrid orbitals are going to form. So they are all sp3 orbitals. Okay? And then you have all of these are sp3 orbitals, and then they are ready to form the bond with hydrogen orbitals which have 1 electron. Hydrogens. Anyway, I told you these are the details. I'm not going to ask you any of these in the exam. So I want you to go over pages 10 and 11, 12, and 13. This study guide, if you would like to ask me any question, ask. What I want you to know for this course is how to determine the hybridization, how just by looking at this molecule, I would immediately say, oh, okay, the hybrid is sp3, without even bothering to draw any of these in a second. So let me show you the shortcut. I'm sure you will love this shortcut. To determine the hybridization, first you need to have a correct Lewis structure. Okay? Then count bonds, just let me say single bonds. What was another name for single bonds? Sigma, right? And non-bonding electron pairs. So for determining the hybridization, first of all, you need to have a good Lewis structure, correct Lewis structure. Then count the single bonds and non-bonding electron pairs, and do not count pi bonds. What do pi bonds do? Means double and triple. Let me show you what it means. So every single bond is a sigma bond, right? These are all the information from General Chemistry 1. Please go back and review. I'm not going to go over these general material, but very briefly. So every single bond has one sigma. Every double bond has got one sigma, one pi. And every triple bond, one sigma and two pi. So we count sigma bonds and non-bonding electron pairs, but no pi bonds. In methane molecule, in CH4, we only have four sigma bonds. So the trick, the shortcut is always subtract the total number of sigma bonds and non-bonding electron pairs, which is 4 here, minus 1, okay, is 3. That one that you subtracted is going to be s orbital, is to be counted for s orbital. And how many more left? 3. It's going to be p. So what is the hybrid? S1 P3 or just sp3. I told you the hybridization for organic compounds is not going to be more than that, either sp, sp2 or sp3. So if you have total 4 bonds, the first one is considered for s orbital. Whatever is left will be for p orbitals. So if you have 4 bonds, is sp3. If you have 3 bonds, it's going to be sp2. If you have total of 2, it's going to be sp. What if we have a molecule with non-bonding electron pair, like a non-organic example? Like if you remember when we were drawing the ammonia molecule, count sigma bonds, non-bonding electron pairs. How many sigma bonds do you see? 3. And how many electron pairs? 1. So 3 plus 1 is 4. One of them is always for S. 4 minus 1 is 3 for P. So it's S1P3 or SP3. Okay? If you have this molecule, let's determine the hybrid on carbon. Let's determine the sigma bonds first. 1 sigma, 1 sigma. In a double bond, there is 1 sigma, 1 pi. So one of them is sigma, and we don't care about the pi bond, right? So how many sigma bonds do you count around the carbon? 1, 2, and 3. 3 bonds. First is always for S. Out of 3, how many left for P? 2. So it's sp2 hybrid. So you see how fast you're determining it without any mistake? Let's determine, I'm working on page 14, by the way, of your study guide. Let's determine the shape. sp3 hybrid. If there are all 4 sigma bonds, shape is tetrahedral. They're all again from chemistry 1. So if you have 4 sigma bonds, the shape is tetrahedral and the bonding angles are 109.5. And the example I told you, it was CH4 molecule. But if you have 3 sigma bonds and 1 non-bonding electron pair, it's going to be, again, let's just go with the same non-organic example, because this is the first thing comes to my mind now. So the shape, do you remember we would consider it as a trigonal pyramidal? Trigonal pyramidal. And the bonding angles are a little bit more squeezed because of the non-bonding electron pair. So instead of 109.5, you had 107. And if you have 2 sigma bonds and 2 non-bonding electron pairs, again, I go with a non-organic molecule, water. These are the common molecules in general chem. So you have a bent molecule and the bonding angles are more squeezed to 105. This is for sp3 hybrid. For sp2 hybrid, when you have 3 sigma bonds, then like we just had that example. 3 sigma bonds, right? Because this second one is a pi. So you have an sp2 hybrid, and then it's going to be trigonal planar. And the bonding angles for a trigonal planar are 120 degrees. And finally, for an sp hybrid, when you have 2 sigma bonds, or 1 sigma, 1 non-bonding pair, the shape is linear. For a linear, you have 180 degrees angle, and the shape can be something like this. So for carbon, we said only sigma bonds. 2 of the triple bond bonds are pi. So 2 sigma bonds, then the hybrid is going to be sp and the molecule has a linear shape. So now you can work on what you have on page 14, and I want you to pause to work on these hybridization, how to determine the hybridization based on what you told you, and get ready for how to draw the organic structures.